Hello and welcome to Physics with Amol sir. So this video is for class 12 and we are going to continue with the chapter of current electricity. In the previous video, we saw the introduction to this particular chapter. We saw some of the topics that we have already studied in class 10th. Today, we are going to see two very important topics. One is the concept of current density and the second one is the concept of drift velocity. Okay, so let's begin. So previously we have seen the concept of resistivity. We saw that we can write rho is equal to RA by L. Rho is called as the resistivity. One more name for it is specific resistance. And you saw that SI unit for rho is ohm meter. Okay, that is resistivity. Now there is another quantity that is called as conductivity. Very simple. What is conductivity? Conductivity is nothing but reciprocal of resistivity. Okay, so 1 by rho is sigma. Sigma is called as the conductivity. Okay, once again, conductivity is also an internal property of the material. Okay, it is a constant at a constant temperature. And you can see the SI unit for conductivity will be nothing but ohm inverse meter inverse. Okay, so that is the concept of conductivity. Make sure that whatever concepts that we are discussing here, you are making a note of it. All these definitions formulae you will also find in the notes that I will be sharing with you. Okay, all the definitions are there, but still when you are watching the video, make a note so that you are always remembering it. Okay, so that was the concept of conductivity. Now as I told you, we will see a new quantity today that is called as current density. Okay, so how do we define current density? Current density we denote by the symbol J. Okay, so current density is defined as the current per unit area. Okay, how do we define current density? Current density is defined as the electric current per unit area, that is current density. Okay, what will be the SI unit? You can see SI unit of current is ampere and for area is meter square. So SI unit for current density will be ampere per meter square. This is the concept of current density. Now current density is a vector quantity. Okay, in this formula we have seen only the magnitude, but there is a way to find out the direction for current density as well. Okay, for that we are going to derive a relation between current density and electric field. Okay, so if we have a conductor from which some electric current is flowing, so it has a electric field to it. Okay, so we will find a relation between current density and electric field. Let us see how. First we will see our Ohm's law. I hope you remember the Ohm's law, which says V is equal to IR. So this is the Ohm's law, V is equal to IR. Using our knowledge of resistivity, in place of R, we can write it as I into rho into L by A. This you will remember when we had seen the concept of resistivity. R we know, we can write it as rho into L by A. Please take that definition for it. So we get V is equal to I, rho into L by A. But you can see I upon A is nothing but the current density. So this relation becomes V is equal to J rho into L. And we'll call this equation number 1. Okay. Now if you remember, if E is the electric field, we can write E is equal to V upon L. Electric field is potential difference per unit length, or V we can write as E into L. Okay, let us call this equation number 2. Comparing equation 1 and equation number 2, we see both the LHS is V. So we can compare the RHS. What do we get? We get EL is equal to J rho into L. Obviously you can see that the L gets cancelled out. So we are left with E is equal to J into rho. This is the relation between electric field and current density. Now this is in terms of their magnitude. In terms of direction, directly you can add the vector form to this. Okay, what you will get? Electric field, that is vector E is equal to vector J into rho. Right? So you can define electric field as product of the current density and resistivity. Okay. current density has the same direction as that of the electric field. Okay, so this is the required relation. So we can write electric field is equal to vector J into rho, or you can write it as vector J is equal to sigma into E. This rho comes here, so we get 1 by rho, and 1 by rho is nothing but sigma, that is conductivity. So these are the relations for electric field and the current density. Okay, maybe for 1 mark or 2 mark this relation could be asked in the exam, so make sure that you have understood this. Now let us see the concept of drift velocity. So imagine this is a conductor, and inside our conductor there are some free electrons. Okay, the free electrons are free to move everywhere. So let us track one electron over here. Okay, it goes here and it collides with some other electron. After collision, this electron will come here and then this will be the other place. Again, after hitting here, it is going to hit, and after the collision it will come here. Okay, so electrons in our materials, in conductors, free electrons are continuously moving like this. Okay, they are moving, they are colliding with the other electrons. Okay, so we can see this. Let us say in the first collision it takes some time t1, in the second collision it takes time t2, then third collision time t3, so on and so forth. So it is going to keep colliding like this. So we can have an average time between two successive collisions, means t1, t2, t3 up to tn. The average we can find out, and that average time, the average time between successive collisions, we are going to denote as tau. Okay, this tau is obviously in seconds, and this gives the average time between the successive collisions. Now remember this particular quantity, that is tau, for our next part. So what we are going to do now, we are going to find out a quantity that is called as drift velocity. Now what is drift velocity? So as we said, for one electron it is continuously moving like this. Okay, then let us say an electric field is applied. So due to the electric field, the electrons start to move. Okay, the electric field, it gives a potential difference across, and due to that the electrons are moving. So each electron will have some different velocity. Then each electron will undergo collisions. Due to that the velocity will change. But we can find an overall average velocity. Okay, average velocity of all the electrons combined, that we denote as drift velocity, which is given by Vd. Right? So what is Vd? That is the drift velocity. Drift velocity is the average velocity of the free electrons when they are moving through the conductor. Right? And Vd, we are going to give a formula for it. This formula I am giving without the proof. Don't worry about the proof. Okay, we are simply going to take it at the face value. So what is Vd given by? Vd is given by minus small e into capital E divided by m into tau. Now what is the meaning of all these? Of course, Vd also should be in the vector form. Okay, so the drift velocity is equal to minus small e. Small e is the charge of one electron, that I am sure you know very well as 1.6 into 10 to the power minus 19 coulombs, multiplied by capital E. What is capital E? That is the electric field. Okay, whatever is the electric field that is applied, that is capital E. And m is mass of each electron. Tau is this average time between successive collisions. This particular formula gives the expression for drift velocity. Okay, this you have to write down, and as I said, you have to accept it without the proof. Right, now the task for us is to find out a relation between electric current and drift velocity. This is a question that is asked in the exam. Okay, from exam point of view it is very important, and this is the question: derive a relation between electric current and drift velocity. So let us start the derivation. First I will write the formula for drift velocity. So drift velocity Vd is equal to E into capital E upon m. Thought this I will call as my first equation. Okay, you will see that we have taken a modulus, so we are not actually worried about the direction. In the previous formula, you will see that there was a minus sign. Minus sign was there because drift velocity is opposite to the direction of electric current. So in this particular derivation, we are not going to see the directions. We are only going to talk about the magnitudes. So therefore, Vd equal to E into capital E by M into tau. That is the equation number 1. So the situation is something like this. Okay, we have got many free electrons. They are all moving through the material. There is some electric field that is applied. Okay, if this is the direction of electric field from left to right, the electrons will move from right to left. I am sure you know the reason behind it. Okay, so the electrons are moving with some velocity Vd. Now, as we said, the task is to find out what is the relation between electric current and the drift velocity. Now, there are some complicated steps and large number of steps, so keep up with me and make a note of whatever we are doing. So, Vd is the drift velocity. Let us say I give you a time delta t, and if I ask you in time delta t, how much distance will the electrons move? Okay, what is the logic you will apply? You will say, we know that speed is distance upon time. So distance is speed into time. Correct? So how much distance will the electrons travel in time delta t? You will say the distance traveled, I will write it like this. The distance traveled by the electrons will be equal to Vd into delta t. This is the amount of distance they would have traveled. Correct. Then, when they have traveled by this distance, let us say from here to here, the distance is given by Vd into delta t. How much volume will be covered by the electrons? How much volume they will cover when they have moved by the distance Vd delta t? You will say volume will be given by distance multiplied by the area of cross section. Okay. So, in this particular time delta t, the volume that is covered by the electrons, that will be given by modulus of Vd. We are writing modulus because, as I said, we are not concerned with the direction. They could be moving in either direction. We are concerned only with the magnitude. So how much will be the volume? Volume will be distance, that is Vdt into delta t multiplied by the area. This much will be the amount of volume that will be covered by the electrons. Now, let small n be number of electrons per unit volume. Okay, once again, what is small n? Small n is number of electrons per unit volume. This will be equal to capital N upon the volume. Is that correct? So, small n is equal to total number of electrons upon volume. So, how many electrons have moved in the time delta t? You will simply say capital N will be equal to small n multiplied by the volume. Is that correct? So total number of electrons that have moved in this particular time interval, that is equal to small n multiplied by the volume. And how much is the volume? The volume is Vd delta t A. So what we have seen, the total number of electrons that have moved is given by capital N is equal to small n into Vd into delta t into capital A. Okay, this capital N gives total number of electrons that have moved in the time interval delta t. Next, I want to find out what is the total amount of charge that moved in that particular time interval. What will be the total charge? Total charge will be equal to charge of one electron multiplied by total number of electrons. So Q I can write as E into N, and we can see what is the formula for N. So I get total charge is equal to E into N Vd delta t A. I hope this equation is clear. Once again go through the entire derivation to find out. If you can see the total charge you are getting as E N Vd delta t A. I hope till here no problem. Now as I said, we want to find out relation between current. So I am sure you remember electric current is given by charge per unit time. So for the time interval delta t, I can write I is equal to Q upon delta t, or I can write Q as equal to I into delta t. So if I say the first equation Q, this equation I call as 1, and Q is equal to I delta t I call as equation number second. So if I compare equation 1 and 2, I can get the relation between I and Vd. Thus comparing equations 1 and 2, you get I delta t is equal to E n Vd delta t A. You can see that we can cancel out delta t on both the sides, and we are left with current I is equal to E n Vd into A. This is our required equation. Just make one small correction. What I called as equation 1 and 2, they should be equations 2 and 3, because equation 1 was already Vd. Okay, only that one correction I want you to make in the derivation that you just must have written. But anyway, so what we got the relation for current and the drift velocity. So I is equal to E n Vd into A. This is the relation you have got. Now here is the task for you. Now what I want you to do, I want you to substitute the value for current as J into A. J, I am sure you remember, is our current density. Okay, so we know that current density J is equal to I upon A. So I can write I is equal to J into A. Substitute for I, and Vd you substitute from the equation number 1. Okay, I want you to make the substitutions and then find out what is the relation that you get between J, that is current density, and drift velocity. That is the assignment, right? So I hope this concept was understood. On Monday we will have a Google Meet class. In that class you can discuss whatever is the doubt that you may be having with these particular topics. Okay.